Hello everyone, good morning. Um, this time I'm going to talk about kind of another momentum problem. Uh, this problem is just a little bit complicated and a little bit tricky, but if you know that, it's very easy. Okay, so the first of all, this is the question. So you can take a picture or you can take a note, whatever you like. All right, that's the question. Okay, so now I'm going to read out the question very carefully. So at 0.3 kg peg initially at the rest on a horizontal is a fictional surface is stacked by a 0.2 kilogram peg moving initially along the x-axis with a speed of 2 meters per second. So this is before. Okay, so after collision, the 0.2 kilogram peg has a speed of 1.0 meter per second at an angle of theta is 53 to the positive x-axis. Okay, and determine the magnitude and direction of the velocity of the 0.2 kilogram peg after collision. Okay, so once I read out the question, they have a lot of things we need to be very carefully. But starting from the question, it's want to find the magnitude. Magnitude is mean the angle. Okay, so this would be theta. And the direction of the velocity is v. But that situation is what's after collision. Okay, and also with the 0.3 kilogram peg. Okay, so first of all, I'm going to draw a picture separately. Okay, so this is draw a little bit big. So I'm gonna have a two situation. Okay, so this one is before. This is after. This is before collision and after collision. Okay, and I got the direction and this one is v1. This is v1. And this one is v1. This is cos theta. So for here, the theta is, we have to find the m1 first. Okay, so the reason I draw like this is the theta 1 is this one have the magnitude, this one have a magnitude 2. The theta 2 is, we need to find the theta 2. Okay, so for theta 1 from this side is every angle have a 90 degree. Okay, so the 90 is 90. So for the angle of the theta 1 is, okay, so we got 37. Okay, so the angle of the direction is 90 degree. That's why we take off is minus is 57 is 37. Okay, this is before collision, because they have after the collision, you see the theta 1 is 53, right? That's why before collision, because we are doing the before collision. That's why we have to take off 90 minus 53 is 37. So this right here will be theta is 37. Okay, so this one will be v1 cos 37. This one will be v1 sine 37. And then I don't need to talk about the angle care of the sign and y, x and y interaction, because I already talked about in the previous problem. So if you don't know yet, go back to the video and then check it, or you can ask it to ChatGPT or your professor. Okay, so this one is V2. This is after collision. This one will be V2. Okay, so V2 is this one is V2 cos theta 2. Okay, because after collision they have for theta 2. Okay, so this is V2 sine theta 2. Okay, so we just write it. They have for two mass. Kilogram is main mass. Okay, we just started. So I think the drawing finished for right now. So M1 is 0.3 kilogram. Okay, when we see the question. Okay, and also M2 is 0.2 kilogram. M1 is 0.3 kilogram. And what we see is the speed of 2.0 meter per second. So we got for M2, so we got V2. Okay, V2 is 2.0 meter per second. This is V2. This is V2 after the collision. Oh, and also this after is V2F. So this is V2F, V2F. This is V1I, V1I. This is before initial and final. Okay, and this 2 meter per second is I think it's a V2. We look at the back to the question. Initially along with the x26. After collision, V1, they have a V1F2 after collision, I think, because they have a two picture. So I think V1F is V1F is 1 meter per second, because it is along in the x-axis. So I think we need to find the V2F is magnitude and direction. So I'm gonna write for x component, so x direction. Okay, for x direction we only look up for the x direction. We see, or we always write, because they have a mass, so M1 V1 is M1 V1I is equal to, for x we see M1 V1 of cos 37 plus M2 V2 of cos theta 2. So I think this two picture will be drawing from this side. Okay, because this. So this one would be both is after collision, I think, because sorry about that. is after collision. This pole will be VF. Okay, so this one is V1F and this is V2F. Okay, so this is also the V1F, V2F, V1, V1 of sine 50, V2 of sine 50. Okay, so because we already find the before collision, because before collision is we don't need to find nothing, because the question is asking the after collision. That's why we have to use the after collision in this diagram. So it's very simple, okay, because of the question. So I thought I used this size this diagram, but I didn't read out the question, so that's why it might be a little bit confusing. I'm really sorry for that. So that's why we use M1 V1F cos 37 is here. M2 is M2 V2F cos theta 2, because we don't know the theta 2. Theta 1 is given in the question, so that's why we write it to theta 1. So when we plug in, M1 is 0. I think plug is 0 moving initially. So that 0.2 is this is M2 and this is M1. Because M1 is 0.2 kilogram is stuck by moving initially. That's why this is M1. Initially always starting first, right? And then this plug is will be after collision, because 0.3 kilogram is right here, is given after collision. So this one will be M2 and M1. So we just write M1 is 0.2 kilogram and V1 is V1I is 1. V1I is the speed of 2 meters per second. This would be V1I is 2. So this is V1 and M1 is the same thing, 0.2 V1 F1 cos 37 plus M2 is 0.3 and V2 Fs we don't know, it's cos 32. So 0.4 into 0.2 cos 37 plus 0.3 V2F cos 32. So when we solve this, 0.4 minus 0.4 minus 0.2 cos 37, which is equal to 0.240 0.240 divided by 0.240 divided by 0.3, which is equal to 0.8. So V2 cos theta 2 is equal to 0.8. Okay, so this is V2. So we got this equation 1. So for y direction, it's the same thing. Y direction is here, so this m1 v1 would be 0 for the y direction, and m1 v1 v1 of sine 37 plus m2 v2 of sine theta 2. Okay, so we got m1 is 0.2, v1 is 2, v1 f is 1, sorry, and sine 37 plus m2 is 0.3, v2 f is, we need to find, and sine theta 2 is 0. Okay, so when this one is plus, for the y direction is, the one is here, is going down. This is the y direction for this one. Okay, the y direction is going down, that's why we need to change the direction is minus. Okay, it's also the change is direction is minus, so this is minus is going this way, this side is 0.3 v2f sine theta 2 is 0.2 sine 37. Okay, so we want v2 of sine theta 2 is equal to let's divide us 0.2 sine 37 divided by 0.3, which is equal to 0.40. This is equation 2. So we're gonna do equation 2 divided by equation 1. Okay, so 2 divided by 1, because we know the sine and cos. Sine and cos is tangent, right? That's why we want to find a very easy way. So v2 of sine theta 2 divided by v2 of cos theta 2, okay, which is equal to 0.40, 0.8. So we, oh no, this one is v2 of tangent theta 2, there's no cancel, okay, it's equal to this one is cancel off, so v2f is gone, so 0.40 divided by 0.8 is 0.5. So theta 2 is, this is tangent inverse of 0.5, tangent inverse of 0.5 is 26. Okay, so we got theta 2 is 26, and if we know theta 2, we can find v2 too, right? Because the question is asking the velocity too. So to find the velocity is we're gonna plug in the after collision for the one direction. So v2 of sine theta 2 is 0.2 40. V2 of sine 26 is 0.40. So V2 of sine inverse sine inverse. No, it's sine 26. Sine 26 is 0.43. So 0.43. So we're gonna divide it by 0.40 divided by 0.43, which is equal to V2F is 0.930 meter per second. So I think my answer would be wrong, because I don't really know about this question. I don't really understand about this one, because it's kind of like a little bit tricky, because I have two picture. I'm gonna stay figure out, and then might be pushes later again for this one, because it's like a little bit tricky question. Okay, or you can ask your professor or ChatGPT if you don't stay understand the part. Okay, I'm sorry about this one, because this one is kind of a little bit tricky, and the moment then is easy, but it's not like a plugging question like answer. We need to find this question like this. All right, so I see you in the next video. Thank you.